Welcome everyone to Fabric Online Conference. And in this session, we are going to talk about real-time intelligence. A quick introduction about me. My name is Surya Teja. I'm a senior product manager in Microsoft Fabric, working full-time on real-time intelligence. So anything related to streaming and real-time will be my area, right? So we'll take this session in a structured format. So we'll talk about the why we had to bring in real-time intelligence, answering the question of why, then the what is actually present, what are the components inside real-time intelligence, and then we'll also try to look at some demos in order to how we create that end-to-end streaming architecture inside Microsoft Fabric. So let me start with a demo first so that you try to get an idea about how well this real-time intelligence is built, right? So what you're looking at is actually a game that I'm playing on my Xbox. So while I'm actually playing the game, I'm able to actually stream the data from my game into the real-time intelligence part of my Microsoft Fabric, right? So you can see while I'm actually playing the game, that while I'm changing my car or while I'm actually going from one place to another, trying to hit a roadblock, you'll see a lot of things changing in real time here, right? So for example, here I've made changes to my car a couple of times, right? Immediately after I change my car from a BMW to Audi, you see that this particular dashboard has changed. I'll talk about what the dashboard is in a minute, but you will see that we are able to change and react to the changes happening in real time to this form of streaming data. So imagine number of industries you are able to cater to when there is milliseconds to seconds amount of data that is emitting out of your systems, and we are able to react to those systems in real time as well and make sense of such a data, right? Now here in this example, you're seeing just like I'm changing cars, I'm going from place to place, and whenever I'm actually hitting a block or something, you can also look at the acceleration graph here, right? So you see the x-axis and y-axis actually changing. When I'm hitting a block, there is a deceleration in that particular axis. If I hit a block or if I take a jump, you are able to see that the y-axis, which is the orange part of this particular graph, that's actually taking a spike here, right? So in this example here, you see in a second that I'll take a huge leap. Yeah, you see there? Once I actually jumped, you'll see that particular orange graph will immediately spike here, right? Meaning I took a jump in the y-axis. Along with that, what I'm able to also do, not just react in real time, but also able to act in real time. So with a particular component present in real-time intelligence, what I've done is I'm looking at the tire rotations here and seeing if the number of tire rotations become less than 20 or greater than 150, then send me an alert on top of that, right? So here, as soon as I'm able to actually go and pause my game, the tire rotations become very, very less, right? So you'll see that in a second, I'll actually receive an alert to myself in my Teams channel, right? Right. You see that the car is either moving too slow or too fast. So that's what a data activator does. I'll actually talk about all the technicalities of real-time intelligence in a minute. But you see, with pretty much a very easy to use solution, I'll be able to stream the data from any form of my system. This could be a game, this could be a power plant, this could be any form of manufacturing plant, healthcare industry. The use cases of streaming and real time across industries are multiple. We should be able to cater to those kind of streaming in real time, right? So that is what we are trying to solve. So the first, and answering the question of why, today our world is exploding with high granularity data, meaning our systems are able to emit telemetry, metrics, traces in real time in milliseconds, seconds, minutes of latency, and we should be able to make this a competitive edge to our customers. So that's what we are trying to see. How can customers make use of this streaming data and make sense of that data in real time? That's what we are trying to solve. Let's look at some industries now, right? This is just a very, very small list of all the industries where real-time use cases are present. Taking examples of automotive, you have connected cars. one car going on road able to communicate with all the other cars. What is the distance between two cars? What is the weather condition? Should we take a reroute? What is the user behavior with the brakes and clutch of that car? Is there any charging and discharging pattern of the batteries inside the car? There are multiple different things we should be able to look at in real time. So connected cars is one example. In manufacturing industry, if you take an example, then you have machinery. What is the quality of the products that is coming out? Is there any problem with the machine? Can we create kind of a command and control center where your shop floor people are sitting and able to see at all the machines happening and working in real time? If there is a problem with one machine, am I able to take decision in real time to fix that? Sometimes even doing a predictive analysis so that we are always ready and our business is not affected in negative way because we are not able to take decisions in real time. Similarly, in logistics and transport, consider a parcel that is going from a sender to the receiver. All along the way of that parcel, there are multiple scans happening. If the product is actually fragile, is there a problem with the delivery method of that particular package? Should we reroute or change the delivery method so that it will still reach the receiver on time? So you have to be able to make sure all the updates in real time are going to the sender, receiver, and also the organization sitting behind, making sure everything is in place so that the package reaches from sender to receiver in time and in right condition. That's one example in logistics. Finance and insurance, you are maybe looking at fraudulent credit card transactions or POS terminal sales. Should I be maintaining my inventory? Can I actually predict how my inventory has to be in the future? Are there any anomalies inside my sales? Right? Kind of creating a sales dashboard. So if you can react to these in real time, you're pretty much allowing your business to also go into profits and also make those decisions in real time. So I don't want to really exhaust this slide, but you get the idea that every industry has this real time need today. We are no longer looking at the data in batch mode. We are looking at the data in streaming mode now. And this is the examples that you can see in the physical world. Now, if we can shift our view towards the digital world, right now, a lot of enterprises have their large Azure infrastructures, large VMs running, many number of VMs running. Now, imagine you are actually monitoring who all are logged in. What are the user analytics on top of each of these infrastructures? Is there any of these service costing more? Can we make changes to this infrastructure so that we are rightly placed and it is costing us less, right? So like use case basis, here also we are able to actually react to the streaming data. How many VMs are running at the moment? Any VM did any VM go down? Can we bring that VM back up by looking at any kind of predictive seasonal or trend on top of that particular infrastructure, right? So even in the digital world, not in the physical world itself, there are multiple use cases. Your system logs, audit logs, login, any kind of malicious behavior, any kind of security or forensic investigations that you have to do, all of that need real-time data. So now that we have got our minds going on the use cases of streaming and real time, we are also trying to solve one more problem here. For every little thing, for every little capability where you want to create a streaming architecture, there is a different product. Now it is on us. It will be our headache to stitch together all of these. You want to get CDC, you depend on Debezium. From Debezium, you have to send the data to another product where you want to do analysis. In order to visualize, there's another product again. So again, this is what we are trying to solve by bringing in together more of the SaaS experience that Microsoft Fabric provides for streaming also. Now we have brought in all the goodness of the tried and tested streaming services in Azure, which is the Azure Event Hub, Event Grid. For doing streaming transformations, we have Stream Analytics. For log analysis, for any kind of time series or geospatial, we also have a very powerful engine, which is through Azure Data Explorer. By bringing in all of these into a more SaaS experience that Fabric provides, everything will be no code, low code based. And all these particular things inside real-time intelligence will also conform to the norms of Fabric, which is the single data estate with one lake, open format, data format, which is Delta Parquet. For your visualization, you can still use Power BI along with whatever we provide within real-time intelligence as well. And of course, we are also bringing in into public preview, which is known as Data Activator. This particular service lets you actually monitor certain properties of your incoming stream, and you are able to take those decisions by acting or alerting in real time on those properties. For example, you are looking at all the telemetry you are getting from EV cars. If there is an event which is saying that, hey, my battery discharge of a particular car is going below 20%, then trigger an alert to that driver, trigger an alert to the nearest store manager so that they can go and charge that particular car there in that store. Right? So that's just one example. But Data Activator here, simply put, using UI and UX, it is able to say, this is the stream I want to monitor. These are the properties, and this is a particular condition I want to look at on top of that property and take action or send an alert on top of it. So all of this clubbed together is what is called as real-time intelligence in Microsoft Fabric. You'll see how this is in action in the next couple of slides. Now that we have got an introduction to real-time intelligence, let's also think about the user journey. What can a user do in order to create that streaming architecture end-to-end? We'll start with selecting our source first. These sources could be cross-cloud streaming sources: Amazon Kinesis, Google PubSub, Confluent Kafka, Apache Kafka, or you might be having native Microsoft connectors like Azure Event Hub or IoT Hub. Also, you can also now react to changing data in your databases. So we have brought in a bunch of CDC connectors, including Azure SQL Database, MySQL, Postgres, and Cosmos. So you select your source. This could be changing data from your databases, cross-cloud connectors, or native connectors. For example, let's consider Azure Event Hub, where you're getting multiple events from one of your devices or one of your manufacturing plants. From there on, where you start inside the real-time intelligence is Real-Time Hub. Now, if you heard about One Lake Data Hub, which is kind of a view or a catalog view of all the different data at rest, Real-Time Hub is similar catalog view of all the data that is streaming and in motion that you have access to. Your organization might have already created certain Event Hub or IoT Hub, and you might be having access to those. So you don't have to always start from configuring them from the scratch, but rather you can pick up a particular source that you readily see inside the hub and start creating your architecture. Of course, when you don't have a connector or streaming source that is listed there, you can always say, go and get your events from a new connector that we support today. Now, once you start from the real-time hub, you have selected your source. The next thing is to ingest and process your source. That's where event stream comes into picture. So inside real-time intelligence, there are a couple of components that you can very easily integrate using the UI of Fabric, starting from event stream for your streaming sources. So you've selected your source. The next in the user journey is you want to process this data and ingest the data, right? So again, using that no-code experience of event stream, which you'll see in action pretty soon, where you'll say, this is a source. These are certain streaming transformations that I want to do. And they eventually send the data to multiple destinations. So you can aggregate your data, you can join your data, union between two streams, or you can do certain windowing transformations, tumbling window averages, tumbling window sum, minimum, maximum. You can do certain data type changes, right? Certain no-code streaming transformations, and eventually send the data to destinations. And in destinations as well, you have multiple of them. One is you can directly send to a lakehouse inside Fabric in order to do more relational kind of analytics using SQL. If you want to do more kind of analysis on top of time series data, graph data, and in real time on semi-structured data like JSON or XML, the right place would be something like a KQL database or what we call as event house. Or From event stream, if you really have that urgency or low latency alerting requirements, you can directly send the data to a reflex or a data activator service. Now, what I've just talked about is setting your source, looking at them, connecting, and then process, analyze, monitor, and act. So process happens, ingest and process happens in event stream. Analysis happens inside event house. Monitor is where you can look at, create kind of a dashboard that is more real time in nature on my time series data. That's what real time dashboard provides you. And finally, act. Act is where data activator comes into picture, the one that I was just introducing, wherein you can monitor certain attributes and take actions on top of it. Finally, we have AI powered intelligence. What do we mean by that? So just like other experiences and workloads in Fabric, even in the event house of real-time intelligence, you're able to use the co-pilot experience in order to ask questions in a more natural language and get back your queries. So inside the event house, you write and do analysis using something called as KQL, Kusto Query Language. And if you're very new and if you're in the learning phase of KQL, if you're familiar with App Insights, Log Analytics, or Sentinel, you might already be familiar with working with KQL. But fairly, if you're new and if you're just getting started, or if you're a business user, you can ask the question in a more natural language. Hey, show me all the different charging patterns of my EV vehicles, or show me the count of vehicles in the last 10 days that have been getting all the events, right? Create a pie chart showing the distribution of how many vehicles are going in a particular region on a particular date. So you ask the question in natural language, English, and you get back your queries. So all you have to do then is insert and run those queries, right? So this is the starting point. Whatever I've shown now, whatever I've talked about, that is more put into an architecture diagram here. As simple as whatever we have discussed. Select your source, that data streams into event stream. You can do some streaming transformations there. If you have very low latency alerting requirements, send directly from an event stream to a reflex, or you can do the analysis inside event house. Inside that event house, now you have large number of analysis capabilities. This could be time series data analysis. This could be graph. This could be vector search, right? So all those capabilities are available in event house. Then you can, of course, rely on either of real-time dashboard for kind of like 1 second refresh intervals, more of a time series visuals. Whereas for more relaxed KPIs, you can always go for sophisticated visualization tool like a Power BI as well. And KQL query set is kind of like the canvas that is provided you, where you do the transformations, where and also where you write all the KQL queries in order to do analysis on top of the data that's sitting inside your event house. Now that we have discussed about the architecture of the architecture and implementation of real-time intelligence, let's also look at what this provides. So an end-to-end event-driven architecture, you can create that end-to-end ingestion, analytics, using the Copilot and AI features, creating a dashboard and acting on top of it, everything within the Fabric UI using real-time intelligence components. Let's go to each of them one after another. Let me start with event ingestion. So here, like I said, we always start from the real-time hub, where I'm able to look at all the streaming sources I already have access to. Single place where everything is visible. I can switch between the Fabric sources and Microsoft sources on the top. And if I do not have my source, I can always click on Get Events on the top here. And this kind of a data source window opens, data source wizard opens. And that's where we actually start at, right? So we start at Get Events, sorry. And here in this particular example, we are selecting Confluent Kafka, for example. Everything again is configuration based, no code, low code, UI, UX based, right? Here I'm giving all the details of connecting to my Confluent Kafka. And then from real-time hub, it now says, okay, now you can go to event stream where the actual ingestion configuration and the destination configuration happens. You can simply click on open event stream. Everything is seamlessly integrated. Now we land into event stream at this point. You can look at the data preview. What are the incoming bytes, outgoing bytes, do any transformations. You see, like I said, all the no code UI based transformations are provided here. And then you can select your destination as well. And even in destination, maybe you already have a database inside your event house. You can just provide all the configuration and the data immediately starts streaming. What we started was very minimal architecture of just choosing one particular database. But what you're now looking at on screen is actually the complexity of what we can build with event stream. You can do data type transformations, you can add more date time fields, do some date time differences between two columns, right? And then you can send it to one database. Maybe you also want to filter out a larger stream using a particular column. Maybe I'm having a worldwide stream. I might be a manufacturing company having a worldwide stream. From that, I want to just filter out the stream related to Europe and India. Right? I can create one filter where I'll say where my source region is India and create another stream. We call this as derived stream. Based on the content of your incoming data, you can filter out and route the data to multiple destinations and also create derived stream. Once you have this derived stream, because this is another stream that you created from a default stream, this will start showing up in your real-time hub. Now, anyone else in India don't have to create this entire process of again filtering, again doing any changes. They can just pick up the derived stream and create their destination or transformations from that point onwards. So here in this example, you're seeing multiple things. One is some changes to the fields, sending it to a time series database like a KQL database or event house. Then I'm doing a tumbling window operation, creating a derived stream and saying, hey, I have a custom application external to Fabric, right? And I want to actually read the data out of Fabric and use it in my application. So you can create a custom endpoint that could expose a certain event hub, an AMQP, or a Kafka endpoint. You can use either of those three. And finally, I can also send the data to a lakehouse, like I said, for doing more relational kind of a analysis. So this is how you do the data ingestion. Next comes the real-time analytics part of it. On the top, you see I've sent from by doing certain data type transformations or adding fields, I've sent it to one database. So let's jump into that database, which is the second part of this, where real-time analytics happen. Now I'll choose my database here, and from within event stream, you simply click on open item, and it takes you to the UI of your KQL database or the event house. See here, you can see this is the event house, kind of a housing or a cluster having multiple databases. I have two different databases. One is operations, one is sales. I can always have the context. Looking at this overview page, I can have multiple things. What is the overall amount in my event stream? What are the different databases? What is the activity? And you can switch the context as you like. You can get the context of all the data and queries run and other overview things, kind of monitoring things at an event house level or at a database level or even at a table level. Now, in this example, I'm already getting a certain stream into this database. Now, in order to enrich that data, I've brought in other dimensional data as well. In this example, I'm just bringing customers' data using a local file. Just upload the local file, and that also shows up here. And eventually, you can start writing your queries now. These queries will actually include your KQL queries. You can also write partly SQL also, right? You see, we also gave a window where you can select SQL queries and you can run them. But generally, the recommendation is to use KQL because we have lots of functions, complex machine learning functions, complex time series geospatial functions inbuilt into this particular query language. Now here in this example, I'm just saying, hey, give me the count of all records that are coming into the real-time data, or get me any 100 records, random records, so that I can profile my data, right? So The Kushto query language is also very, very easy to pick up. We also have lots of resources where you can start from scratch and learn KQL step by step available today, right? So that's where real-time analytics comes into picture. Then let's get into the real-time AI part of it. So the artificial intelligence, how are we including AI? And you'll see that there is a co-pilot button inside this event house. You click on that and start asking your natural language questions. So here, because this is sales data, first we could ask something like sales data across all sales by sub-region, show me in a time chart, and observe something here. We have not given any context of what table you have to get the data from or what columns you have to get the data from. It understood that the sales data, fact sales data is available in this push all sales data. It understood all the columns and the context, and it gave you a query back. Simply click on the insert button and run it. So there you go, and insert and run, and you'll see a beautiful time chart. That's another beauty about Event House. Within this particular database and the query canvas, you are also able to do some exploratory data analysis, look at the profile of your data in more of a graph format rather than just looking at a large table with a lot of records in it, right? And here you're able to do all sorts of anomaly detection, outlier detection, map visuals for geospatial, bar chart, column chart, stats, everything is possible from within the query canvas itself. In this, again, continuing with the example that is being shown, you are able to now add more context to the question that you previously asked in order to have a more granular look. Here, what I'll ask is just show me the last week's worth of data where the number of items sold are greater than 20. So the same question, but with added context. That's what I'm trying to do here, right? So only count sales in the last week with greater than 20 items, right? So once I do that, we get a more refined query. Again, insert and run it. You see the graph is also changed according to that. So the possibilities are endless here in the sense every industry you choose, there will be certain streaming need. At the start, I've shown kind of a gaming industry and also automotive industry. It caters to both. You're playing a game and you want user analytics, how many people are playing, what is the user behavior in a particular, what is the action a user is taking. The logs can always come to such a real-time intelligence workload. Also automotive. If you have hundreds of cars or EV vehicles on road and you want to see what are the different patterns of those cars, how are they communicating with each other, all those telemetry can also be streamed maybe via an eSIM into our real-time intelligence. And then you can start making sense of the data. You can write queries, look at visuals, create more business-oriented visuals also using Power BI, right? Now let's go into the next leg of this, which is the real-time dashboard. So here we have seen, I was able to create a very neat time chart here, looking at the aggregation that I wanted. For real-time dashboards, you have two things here. If you observe closely, there is pin to dashboard and there is also build Power BI report. The dashboard, like I said, is more oriented at real-time time series kind of a data. So you are able to set the refresh rate of such a dashboard to 1 second as well. And then there's Power BI report for more business-oriented things. Like you want to show some KPIs, you want to have like 15-minute, 20-minute aggregated view of certain data. You can, of course, rely on Power BI report as well. And again, because everything within Fabric is neatly integrated, once you click on build Power BI report, you don't have to go through the hassle of again creating an empty report, making sure your connection is established to this particular database and all. It will automatically create the connection and give you a blank report where you can start using Copilot again inside Power BI or building your own reports on top of that. So here in this particular example, once you click on pin to dashboard, it will ask you, hey, do you want to create a new dashboard altogether, or do you want to just add this to an existing dashboard? And again, the complexities and the possibilities are endless within real-time dashboard. You can create a very, very complex dashboard like you see on screen. It could be having very frequently changing stats, line charts, anomaly detection charts, even forecasting charts. And you can actually change the query or work with your query or go into editing mode at any point of time. And when you want to present this to business, they don't want to look at your query, right? They want to look at how they can explore just by adding and doing drag and drop. That is what we cater to. We cater to more of citizen developers also, citizen business developers also, right? Now, that is where the exploratory data analysis of real-time dashboard comes into picture. Once you, let me take a step back here. Once you have a certain dashboard ready, every visual has a very small explore icon here. So, sorry, yeah, explore icon here, the one with the small search box. So here, sales by region, let's pick that up. Once you click on that, you'll be taken into this screen where on the top, you have your query that's written. Now, no need to write any query. Just keep on adding your filters or aggregates that you want. And you can also change your chart and look and feel of your particular chart that's showing up. So here we are just adding another filter, and immediately you can see, like, you can, from the drop down of visual type also, you can change what kind of visual you want, right? So that's how you can do exploratory data analysis instead of writing your query. It's all drag and drop and keep on adding whatever where condition, whatever aggregation that you want to do on top of this. So that's real-time dashboard. And then let's get into the real-time triggers part of it. So this was something that I've been talking about, which is data activator, which lets us take any action, right? So from here, if we go back to our dashboard, you can see, you can click on any visual and you'll immediately see set alert. Now, one thing I have to clarify here is not just on real-time dashboard. You are able to directly send a stream to a data activator or even set an alert on Power BI dashboard also. If you have some visuals in Power BI, just right click on any visual and you'll see set alert on top of it. So that is all happening through data activator. Here, once you click on set alert, such a side pane opens where you can select if I want to send an email, or if I want to send a Teams message, or if I want to trigger any other Fabric workload as well, right? So you will see that very, very shortly. For example, if you have something getting added to a particular storage account, blob storage, then you want to trigger a Fabric pipeline or trigger a Spark notebook. That also can be done through data activator. But coming back to this particular example, here what I'm saying is, okay, look at the cost. And if the average cost is greater than 3,200, send me a Teams message. And once you are done by setting this up, you can also go to a complete design experience of data activator itself. So once you click on create here, you'll see you'll get something like an open, and you open, you go into the data activator experience, kind of the last leg of creating your streaming architecture, right? We have got our stream, we have done analysis, we have created a dashboard. Now it's time to act on that, right? So you can see you have all different kinds of triggers you can create by setting up certain conditions. So this is what we have set in the other window. You can add more filters, you can add more criteria to your condition here. And what we are trying to say here is, okay, if my particular cost, average cost goes greater than 3,200 and stays at 3,200 for 10 minutes, then only send me an alert. Or every time you get a record or an event where it shows cost is greater than 3,200, send me a message. So you can switch between how you want to monitor, how long you want to monitor before sending an alert as well. And that's what it does. So as soon as you do that, you'll start from that point onwards. You'll see that this particular data activator has already started monitoring your data for average cost. And then it will start sending you Teams messages and other sorts of things, right? I'll actually show you an example of such a Teams message as well. And finally, let's look at event-based triggers, event-driven triggers, right? So what are these? If I go to real-time hub, where we all started looking at, right? So we are able to actually say and go to the tab called Fabric Events. So here you are able to say, hey, trigger a particular workflow if a file is getting added or deleted or modified inside my Azure Blob Storage. Or you are also able to say, hey, if a particular item is getting modified or created or deleted inside Fabric Workspace, then also trigger a particular workflow. This could be a pipeline. For example, your company is sending data into a blob storage continuously. Now you want to trigger a data pipeline so that whenever new file gets added into your blob storage, your pipeline will go pick up that file and load it into a database. So that could be one such thing. So you can trigger a Spark notebook also in order to do any ETL on top of that file before landing it into a database. So that, again, the possibilities are endless here. You can react to Azure Blob Storage events and workspace level events, workspace item events inside Fabric today. So that's what we call as event-driven actions that you can use. And this also opens up data activator experience, where you can set up what is a pipeline that I want to trigger? What is a condition that I want to see? If do I want to just monitor a file getting added, or should I want to monitor a container getting created as well along with files? Multiple of these events are already present at blob storage level. So those are all the different things that real-time intelligence lets us do, an end-to-end event-driven architecture, right from ingestion to taking actions. Now, can I have a time check, please? How long do we have?
Yeah, sure. It's you got about 20 minutes. If you could maybe finish in the next 10 to 15, that'd
Awesome.
be good. Thank you.
All right. Okay, so at this point of time, let me also switch to my experiences, right? So this is my Fabric workspace, and I've created multiple of these streaming architectures. Here, you're looking at a lineage of how the data is moving inside Fabric. Now here, the one that I've shown, Forza Horizon, that's the game I was playing on my Xbox, and it is getting into event stream, the same simple architecture we have seen. Event stream to a KQL database where I'm doing certain analytics, and then creating a dashboard, writing some queries, or creating an alert on top of it. So everything possible end to end here, right? So that was the Forza Horizon example you saw in the dashboard. Now let me also go into a couple of other examples to show you just how powerful the engine that's running real-time intelligence is. Here, I also have something else, stream stocks. So inside event stream, if you are starting with event stream for the first time, we have also provided certain samples, a bicycle related data, how many bike stations are present across London, in what street, in what particular neighborhood, how many bikes are present, how many empty docks are present, and different other data, right? So that's kind of a streaming bike related data. Then we have also provided yellow taxi data. So taxis going around New York, how many people got into the taxi, what is the latitude and longitude, what is the price of the taxi, what is the fare, all of those things. That's the second kind of sample we have given. And the third is stock market data. So the one that you're looking at right now is a sample data I've actually got, right? So when this is the event stream experience, by the way, right? That's what we have seen. Here I've shown, okay, I'm able to look at all the data preview of my sample that's coming in. What is the symbol of the stock? What is the retail, and what is the bid price, ask price, how much it was sold for, and so on and so forth. And every record has a timestamp attached to it. Now that I can look at the preview, I'm saying, okay, all okay, my data is good. Now I want to send it to multiple destinations. I have one external applications for which I've exposed an event hub endpoint. You can look at all the connection string. Maybe it might be a Java code, it might be a Python code. There you are able to connect to this particular event stream and able to get all the streaming data that you have. Or the recommended approach of creating a real-time architecture, which is sending the data to an event house. Eventually here also, like every node here, I'm able to see the changing, the incoming stream, right? So even in the destination node, I have actually given what all different databases I have to send the data to. Here, because this is stocks data, I've created a database inside my workspace, and then I've created this particular database as well. Here, I'm sending the data to a KQL database. Let's jump into the KQL database now. Here, this is a particular event house, and event house has this particular KQL database. And like I said, we can see all sorts of overview and monitoring of how things are inside this database. What is the overall size, which is 38 GB, and the compressed size is essentially 2 GB. So that's another beauty of this database. It automatically applies a certain compression to your data. So you don't have to do anything. The database itself indexes all the data, it compresses, and what you are built for essentially is the compressed data inside the lake. And you are able to look at how much of data is incoming per day using a histogram. And then you are able to also go into the context of a table and monitor the activity on that table also, right? With data, you see the data preview is coming, and then you are able to also look at the schema of that particular data and everything. So from here on, I know my data is actually coming into my database. I can go into the query experience and start writing my KQL queries. I want to look at 100 random records. So you see all the data. This is the data, and I have all the records here, all the tables here. And as soon as I say take 100, which gives me random 100 records, I'm able to just look at and profile my data. How is the data looking? What are the data types? I can look at how many, you see, I can, like I said, you can also write any SQL query, very basic SQL queries. Yeah, it works along with KQL. And then on, you can start doing, any kind of more analysis, that exploratory data analysis. You can go into more of complex analytics of doing anomaly detection, forecasting, behavior analytics, all of those things, right? So these are very, very basic things. Here, for example, I'll say, okay, show me how many count of different stocks and how many records have you got here, right? I got it just by using a count by symbol, almost like a group by that you do in SQL. Now, if I'm okay, I just want to monitor my data incoming and look at the distribution of how the stocks are. I can then say pin to dashboard. This is what we have seen in the recordings as well, right? Once I do that, I'll eventually land into something like this here. So this is a real-time dashboard. And I've created, just for the sake of demos, I created 2 simple dashboards here. You can, of course, change all of these. This is a time chart. This is a pie chart. And like I said, if you go into manage, if you go into the editing mode, you can go to as low as continuous, which is 1 second refresh interval. That's where the power of dashboard, real-time dashboard, comes into picture. It's continuously running queries on the event house, and it is able to keep the data up to date. This is very, very important, especially in like manufacturing or energy, where you're looking at the byproducts and products and like monitoring your power plant's temperature continuously, right? So that's where real-time dashboard comes into picture. And finally, I'll leave you with just showing you the power of the event house itself. So at this point, I'll have to tell you that Microsoft itself is like an internal customer to the event house. So lots of logs that we want to handle, all of them come into this engine, which is the event house engine or the Custo engine. So just showing you the amount of data that is available today, like 2.5 billion records on this particular data set. This is coming from GitHub's API. So there's an API where all the different events happening on the public repositories inside GitHub, push event, pull, commit, delete, all the events happening on public repositories, those are getting streamified into this particular API. So we are getting the data into an event stream and eventually into our event house. So Historically, you can see that right from 2021, we are getting the data into this, and that pertains to almost 2.5 billion records. And if you look at the size of this data, it's 8 TB worth of data. So this particular engine, not to get confused with the real-time name of it, it also can handle high granularity and high volume data as well. You bring in how much ever data that you want, you can retain it for how long, however long you want, 10 years, 20 years, 100 years. It's possible here. You can maintain a hot state and a cold state of your data based on the query requirements, and you can do all sorts of analytics here, right? So, and another very great thing about this is the ability to store your JSON files and documents as is into columns. Say you are getting frequently changing schema inside your JSON, then you are able to see here, for example, payload. You're able to actually say, hey, this is actually changing, so I don't want to create a structure out of this. Because if I create a structure, the pipelines will start failing, saying, I cannot find a column. The data type of column change, mismatch. Wherever I know a column is always existing with a particular data type, I create strongly typed columns. Wherever I see there might be changing schema, I'll store the entire JSON into something called as a dynamic column, and the data is immediately available for us to query. For example, let's look at actor here. This is a JSON that I've stored. So I have like ID, login, display ID. Now I want to just get ID and login out of this. I can always use the JSON dot notation in order to simply extract the fields that I want. This can very well understand however complex your JSON is. Multiple nested levels, multiple arrays inside it. You can explode your arrays into multiple records if you want. It can understand XML, it can understand free text, all power of doing analytics, complex analytics, and that too on streaming data is possible using Event House. So that's what we have actually seen. And finally, I'll show you certain data activator alerts that I've set up, right? So you have seen during that particular demos how you can set up certain alerting conditions. Here, what we are trying to see is after you set up the condition, I have actually configured, hey, send me a Teams alert if something has changed or if the condition has met on my stream. So you can see like I've done multiple different tests. Here I've created certain alert for power plant. If the temperature goes beyond certain point, you can send me an alert. And you can enrich your alert as well. You can add more properties. What is the actual temperature where it failed? What is the status currently? What is the ID of a power plant, for example? All of that. That enrichment can also be done. And of course, because we also very neatly integrate with Power Automate, you can now create any kind of custom action that you want. Maybe you have a team, an operations team, for example, and that operations team has to send an email alert, a custom email alert with all the data to be a business user, a business leader, maybe. Then you can maybe use a Power Automate trigger inside Power Automate. Again, like thousands and thousands of connectors are possible. So you can create your custom email there with a template that is possible and send out an alert. Or if you want to natively use whatever is available inside data activator itself, you can send such a alert as well. Here I'm looking at delayed packages, I'm looking at power plants, and also at some point here you see this is actually the event-based trigger I talked about. I was looking at an Azure Blob Storage and I said, hey, if a particular file got added to my Azure Blob Storage, blob created, send me an alert, right? So these are like, again, here the possibilities are really, really endless. You can either use the native action capability, alerting capability inside Data Activator, or you can integrate natively with Power Automate and then create a custom action as well. All right, so that is all I had to share. Hope you like the content, and I will try to look at Q&A now and try to answer any questions.